Hello. In this video I'm going to walk you through the steps for computing the covariance and Pearson's correlation between two variables. Although I have Microsoft Excel open and Microsoft Excel contains a number of functions for doing this automatically, I'm actually going to show you how to compute using the formula that you see over here for the covariance and the formula that you see over here for Pearson's correlation. So we have data or hypothetical data on two variables, variable x and variable y, and just to make this a little bit more concrete, let's say that our variables represent scores on a measure of anxiety and a measure of achievement for a set of 10 students. So you'll notice that the sample size is obviously going to be 10, and the mean for anxiety is 4.1, the standard deviation is 1.197, the mean for achievement is 5.2, the standard deviation is 2.044. So let's go ahead and begin our computations. So first off, let's look at the formula for our covariance. And in the numerator of this formula, you will notice that within the parentheses we have x minus x bar and y minus y bar. X bar and y bar are both the means on those two variables, x and y. So essentially the first parenthesis says take the raw scores on x, which is anxiety, and subtract the mean for anxiety. The second parenthesis within that states take the raw scores on achievement and subtract the mean on achievement. So what I've done is I've gone ahead and created columns to walk you through the steps here. So we have, in this column, we're going to be forming deviation scores, which is basically taking x minus x bar. In this column we have deviation scores taking y minus y bar. Once you've done that, then you'll need to multiply the deviation scores for x and y together. Okay, and you're going to do that for each case. So I've created another column that represents the product of those deviation scores. And then finally, this is called the summation operator, and you'll sum those deviation scores together. So let's go ahead and walk through this. So I'm going to go to this column right here, or this cell, and I'm going to type in equals, there's x for anxiety, which is a raw score of 2, minus the mean on anxiety, which is 4.1, and I'm going to go ahead and lock this cell right here and drag it down because it's going to be the same process all the way down. Okay, so next what we'll do is we're going to say equals, and then we're going to say the raw score on y, which is 7, minus the mean on y, which is 5.2. Again, I'm going to lock this cell right here and grab this and drag it on down so that all that fills in. So the next step is to multiply those deviation scores. So I'm going to say equals this cell times this cell right here, and again I'm just going to lock this and drag it down. All of these are reflecting the product of the deviation scores. So now we have all of the products of our deviation scores, and then we have to sum them. Okay, again, this is referred to as a summation operator, which is sigma. So you'll notice that the numerator of the formula is called the sum of cross products. So we're going to go ahead and sum those those products. So we're going to say equals sum, and we're going to sum up all the values in this column right here, and then hit enter, and so the sum of cross products is negative 12.2. So finally, to finish out computing the covariance, we're going to divide by n minus 1. So n is our sample size. So we're going to divide our cross products by n minus 1, which is 9. So we're going to say equals sum of cross products divided by 9, and that gets us our covariance, which is negative 1.3556. So now we have computed the covariance. So to compute the correlation, what we'll do is we will just take one extra step, and that is to divide the covariance that we computed at this step by the product of the standard deviations for x and y. So I just really quickly did a little bit of editing just so that to make this consistent. So there's the covariance, and we're dividing that by the product of the standard deviations for x and y. So in this case, we're going to go down and I'm going to fill in this little cell right here. I'm going to say equals there's the covariance, and then we're going to divide this by the product of the standard deviation for x and the standard deviation for y. When we hit enter, you can see that our correlation, our Pearson's correlation, is negative 0.554. Now, to further drive home the association between the covariance and correlation, let's try a different formula for computing correlation, and this entails taking the sum of the products of z-scores on x and the z-scores on y, and then dividing by n-1 that you see right here. So I have these additional columns, so I have zx, zy, and then the products. So what I'm going to do first is I'm going to convert all the raw scores on x to z-scores, so that basically entails taking the deviation scores that we computed in this column and then dividing that by the standard deviation. So we're going to do that, and we're also going to essentially make sure that that standard deviation remains the same, so I have to lock that cell, and I'm going to grab this and drag it down, and then we'll do the same thing for y. So I'm going to say equals deviation scores for y, because to create a z-score it's just the deviation score divided by the standard deviation. So I'm just going to take the deviation scores for y, divide by the standard deviation for y, which is the 2.044, and I'm going to lock that as well, and we will grab this and drag it down, and then finally we'll multiply. So I'm going to say equals this number times this number, and we'll grab it and drag it down as well. Then finally what we'll do is we'll take, we're going to sum this up, so I'm going to say equals sum from this column, and that gets us negative 4.98556. So then to finish calculating the correlation, it's just going to be R is equal to this number right here, divide by n-1, which is our 9 again, and we'll hit enter, and so you can see it's the same number, negative 0.55, roughly negative 0.554, same number right here. So basically what this tells us is that the correlation that we've computed is nothing more than computing the covariance between two standardized variables. Finally, let me just note that if you have a correlation and two standard deviations, you can easily convert the correlation, the Pearson's correlation, back into the covariance just by taking Pearson's correlation and multiplying by the products of the standard deviations for x and y. So let's go ahead and do this. And there you go. So now we have our covariance that we computed earlier. So that concludes this video demonstration, and I appreciate you watching.